This week on the show, we are talking about replacing silently falling disks in ZFS pools. The OPNsense 19.7 RC1 release, we're covering the release candidate. We also look at implementing DRM ioctl support for NetBSD. We talk about higher quality, low latency VOIP servers with umurmur and Mumble in OpenBSD. We look at the PDP-7, where the Unixes began. LLDB watchpoints is also on our things to talk about, and more in this week's episode of BSD Now. BSD Now, episode 308, Mumbling with OpenBSD, recorded for the 24th of July 2019. Hello, I'm your host, Benedikt Kreuzling.
And I'm Alan Jude.
Welcome to this week's episode of BSD Now. We're glad that you tuned in again. And we have interesting headlines for you because it's always good to know how to replace a silently failing disk in a ZFS pool. And that's the article here.
So they start with, maybe I can't read, but I have the feeling that official documentation explains every single corner case for a given tool, except for the one you actually need, as with my struggle today, replacing a disk within a FreeBSD ZFS pool. So they say, yesterday, I felt my personal FreeBSD NAS was sluggish, and this morning I saw some horrible messages in syslog about timeouts on AHCI channel 1. Basically saying that the disk ADA1 was having a read command timeout. So they're like, yeah, that's bad. That disk is probably not going to last much longer. So they ran zpool status, and their 3-disk RAID Z1 looked perfectly happy. And they say, but the input error, output error thrown and smartctl make things clear that this disk is on its way out. So in the default case, when you try to read from a disk, it can time out. And the OS will try 3 additional times, I think, before actually having a hard error. So as long as one of those succeeds, ZFS will never actually note an error. But they say, thanks to past me, there already was a disk ready for the task. There's the disk ADA3 that is ready for them. So they tried to just replace the failing disk with the new one. Zpool replace zroot ADA1P4 with ADA3P4, and they got back the message, can't open ADA3P4, no such geom provider. What a fantastic and explicit error message, just to say that ADA3 hasn't been partitioned. Well, you told it ADA3P4, and there's no such device. But it says, I am no FreeBSD guru and very occasional user, but not used to the whole geom, gpart, geli, etc. But thanks to a very well-written Stack Exchange post, they were able to see that they can do gpart backup ADA0 and pipe that into gpart restore ADA3, and it will copy the partition table from one of your existing disks.
A working disk, yeah.
Yeah, a working disk. I guess technically that is an error a part of the process we didn't cover in the handbook section on this.
Could be, yeah.
When we're doing the replacement.
Yeah, if you just have the disk without any partitioning on it.
Yeah, so probably to section 19.3.5 or 0.6, replacing a functioning device or a failed device. Probably do actually need to add that bit in there. And then, following the instructions given out by ZFS or by the handbook, he added the boot code to it in case his machine decides to try to boot from that disk. And so yeah, they did the replacement. While that's in progress, you'll see a new virtual device called replacing-1 that contains both ADA1 and ADA3. Basically, it's created a temporary mirror while it copies the files over. Now, you see that it said it was going at 40 kilobytes a second. That's because it was just starting. If you give it a couple of minutes, the average will probably have been better than that. But because that disk was failing and he felt like it was slowing the system down, he decided to explicitly offline the device. So he did zpool offline of zroot ADA1P4. And so now when you look at zpool status, you can see that that disk is now just its global unique ID and is offline. And it will get the content to replace ADA3's contents from the other 2 disks. So after a while, it's done. And you can actually see that it automatically removed the replacing device and the offline device once it was complete. Although when he tried to do zpool remove, he was saying there's no such device. And we looked, oh, yes, in zpool status, it's already gone. I think in most of those cases, you actually want to use zpool detach rather than zpool remove. Remove is only meant for like log devices and cache devices. And then eventually you were allowed to remove a disk from a stripe or a mirror. Although actually last week, Matt Ahrens put up an issue on the OpenZFS GitHub describing how someone could go write the code to make device removal work for RAID Z and what the restrictions would be, but noted that he's not interested in doing it himself. He'd love somebody else to do it, and he would provide support and so on. But he described how it would actually work, based on all the lessons they learned making the device removal work for mirrors.
All right. Then next up, we found that OPNsense is busy. They just released their 19.7 RC1, the release candidate. And they write, hi there. For 4.5 years now, OPNsense is driving innovation through modularization and hardening the open source firewall with simple and reliable firmware upgrades, multi-language support, hardened BSD security, fast adoption of upstream software updates, as well as clear and stable two-clause BSD licensing. Here are the full changes against version 19.1.10. So the system got new remote syslog setup via syslog-ng. The gateway handling rewrite was done. They ported the depinger to the plugin framework. They brought back the PHP warning log level so that you can see some PHP errors occasionally popping up. They also used the authentication factory for user import, and made some changes to interfaces like refactoring to VLAN, bridge, lag, GRE, and diff setup. And they also improved the load sequence to allow DHCP version 6 on bridges. Other changes are in the firewall space, of course, and they added an ability to view automatic rules. They also show statistics for all active rules, including automatic ones, rule origin locator in live log and automatic rules listing, and they also provide optional statistics for alias tables. Oh, that could be useful. They also added the bit of reporting for new NetFlow reader in Python 3, and they validate that NetFlow WAN interfaces, wide area network, are also added to listening interfaces. There's quite a good list of changes for release candidate 1, so people should also know that there are some known issues and limitations. The filter log spamming console due to new syslog-ng integration, so there's a lot of messages coming up. There's a temporary workaround by stopping the filter log via pkill filter log. And I guess the RC2 will have that fixed. OpenVPN no longer supports the listening on gateway groups. You use localhost paired with port forwards instead. And the last thing they note is that the web proxy login privilege is no longer available. Access may be restricted by a group selector instead. Yeah, so, and they asked the chest, of course, and please let them know about your experience and anything that you find.
So next we have a post by Christos Salos on the NetBSD blog about implementation of the DRM ioctl support in NetBSD's kernel. So what is the DRM ioctl? So ioctls are input-output control system calls, and DRM is the direct rendering manager, basically the graphics acceleration system in Unix-like operating systems. So the DRM layer provides several services for graphics drivers, many of them driven by the application interfaces it provides through libdrm, the library that wraps most of the DRM ioctls. These include the vblank event handler, memory management, output management, frame buffer management, command submission and fencing, suspend resume support, and all that kind of stuff. So the native DRM ioctl calls, NetBSD is able to make native ioctls for DRM with hardware rendering once Xorg and the Mesa packages have been installed. For example, we use the GLX Info and GLX Gears applications to test this out. You can actually see them running in a screenshot here. But then they look at the DRM ioctl calls from emulation. In order to make sure DRM ioctl calls were also made from the Linux emulation layer of NetBSD, they used RPM and the SUSE 13.1 packages, base, compat, x11, libdrm, libglx, and libexpat. He says, to my surprise, the applications kept segfaulting. He said he used glx gears and glx info RPM packages for this test. When I analyzed the segfaults and traced the process, I was able to identify the cause of the segfaults, which was caused due to a broken libdrm package, which did not support the Nouveau-based graphics cards. To further make sure that the problem was with the SUSE packages, I downgraded to SUSE 121, and as expected, the glx info and glx gears RPM packages ran as expected. But it was using software rendering instead of hardware rendering, but nevertheless, I was still able to see the DRM ioctl calls made by the emulation layer, hence you can see these print statements here. So they say fixing the SUSE 13.1 packages and enabling hardware rendering from emulation is currently the highest priority. I have also planned to port Steam and its dependencies to NetBSD and incorporate some gaming on NetBSD. And finally, conversion between 32-bit DRM calls and 64-bit DRM calls will also be implemented.
Hey, that sounds good.
So this is work done by Surya P. As part of Google Summer of Code 2019. And thanks to his mentors at Christos, at Maya, and at Leo T. Mm-hmm. And obviously to Google for providing the Google Summer of Code.
Yeah, that's a nice program for open source projects to get new contributions and developers ultimately. All right, remember last week's episode where we talked about OpenBSD and Twitch? We have now something from the same author over at dataswamp.org about high-quality / low-latency VoIP server with umurmur / Mumble on OpenBSD. So this one talks about, at the beginning, I hate Discord. Discord users keep telling about their so-called Discord server, which is not dedicated to them at all. And Discord has a very bad quality and a lot of voice distortion. Why not run your very own Mumble server with high quality and low latency and privacy respect? This is very easy to set up on OpenBSD. Mumble is an open source VoIP client, voice over IP. It has a client named Mumble, available on various operating systems, and at least Android. The server part is Murmur, but there is a lightweight server named umurmur. People authentication is done through certificate generation locally, and then automatically accepting that on the server, and the certificate gets associated with a nickname. Nobody can pick the same nickname as another person if that's not the same certificate. And they talk about how to install that. It's fairly easy. Package_add umurmur, and then rcctl and OpenBSD to enable umurmurd, the daemon, and then copy an example config file to etc umurmur. Then you basically want to increase your max bandwidth value to increase the audio quality or choose the right value to fit your bandwidth. And then you have, if you have rcctl, start the umurmurd. And if you have a restricted firewall, you have to open, of course, ports TCP and UDP 64738. How do you connect to that? The client is named Mumble and is packaged under OpenBSD. So we just do package_add Mumble. The first time you run it, you will have a configuration wizard that will take you only a couple of minutes. And don't forget to set the sysctl current.audio.record to 1 to enable audio recording, as OpenBSD did disable audio input by default a few releases ago, so that no one can use your microphone in malicious ways to record you. And then you will be able to choose a push-to-talk mode or voice level to activate a quality level. And once the configuration wizard is done, you will have another wizard for generating the certificate. And the author here recommends choosing automatically create a certificate and then validate, and it's done. Then you will be prompted for a server. Click on Add New, enter the name server so you can recognize it easily. Type its hostname or IP, and then the port and nickname, and then click another OK button. And then congratulations, you're now using your own private voice over IP server for real.
Yeah. Basically, same instructions work on FreeBSD. You just package install Murmur or umurmur, depending if you want the heavier weight or lighter weight server. Use sysctl to enable it, and the path to the config file will be user local etc murmur, but same thing. And yeah, the client works well on all the BSDs as well, which is much nicer. It was one of the things we considered for doing group meetings and stuff in FreeBSD because it actually works on FreeBSD.
Yeah, eating our own dog food in the audio space.
Yep. So next up, we have a story here. It's part of a bigger digest, and we're just focusing on the specific Unix part in the middle of this. But over at softwaremill.com, in their June update here, they say Unix, going back to the roots. And they say, from time to time, I like to review my knowledge in a certain area, even when I feel like I know a lot about it already. I go back to the basics and read tutorials, manuals, books, or watch interesting videos. So I've been using macOS for a couple of years now, previously being a Linux user for some time. Both of these operating systems have a common ancestor, Unix, which I'm definitely not an expert in. But I feel quite comfortable using Linux and Mac. I understand the concepts behind the system architecture, know a lot of command line tools, and navigate through the shell without a hassle. So-called Unix velocity is also close to my heart. I always feel like there's more I can squeeze out of it. Recently, I found a book titled Unix for Dummies, 5th edition, which was published back in 2004. Feels literally like ages in the computer-related world, however, was still a great shot. The book starts with the basics, providing some brief history of Unix and how it came to life, which will fit right into our next story. It talks a lot about the structure of the system and where certain pieces fit, like the standard set of tools, and how to understand permissions and work with files and directories. There's even a whole chapter about shell-based text editors like VI and Emacs. Despite the fact that I'm familiar with most of these, I could still find some interesting pieces and tools that I either knew existed but had never had a chance to use or had never even heard of. And among all of these, I still that they're all still valid in their modern incarnations of Unix's descendants. They list only Linux and Mac OS, but obviously the BSDs are the actually closer relatives to real Unix. Anyway, the book also talks about networking, surfing the web, working with email. It's cute to see pictures of these old web browsers rendering ancient internet websites, but hey, this is how it looked like no more than 15 years ago. And I say, I also recommend this other book, Different Unix Dummies. To anyone working on modern macOS or Linux, you'll certainly find some interesting pieces, especially if you like to go back to the roots from time to time.
Oh yeah, that's certainly a nice trip back into history.
Yes. Speaking of that, though, we have the serial number for the first Unix system.
Ooh, the very first one?
Yes, so this is a post over on Warner Losch's blog, and he did some history spelunking and so on. And he says, in preparation for a talk I'm giving on 7th edition Unix this fall, which will be at EuroBSDCon, he says, I stumbled upon a service list from DEC, or Digital Equipment Corporation, which is the company that sold them, of all known PDP-7 machines. From that list and other sources, I believe that PDP-7 serial number 34 was the original Unix machine.
Oh, wow.
So that would be the machine that Ken Thompson and Dennis Ritchie actually built Unix on. So, building the case that this is the right machine. We know from the SimH sources, the restored PDP-7 Unix version 0 source code, and recollections from the time, that the original machine used by Ken Thompson and Dennis Ritchie had, or likely had, the following hardware. An 8K word of memory, which is option 149B from the order sheet, a tape reader, a tape punch, a 1 megabyte hard drive, a TTY controller for a teletype, so that would actually print on paper, a standard video display, a custom video display, and a keyboard for input.
Ah, yes. These are the order options.
And they say, we know from the service list that Bell Labs had 3 different PDP-7s and 1 PDP-7A. Several of these machines had the standard options, which is a tape reader and a teletype, and extra memory. Only one system, the one with serial number 34, also had a disk drive, which was a custom unknown board that was likely the Bell custom display, and the standard display. In addition, That system shipped to Bell Labs in 1965, and it appears to have been refurbished in 1969. This timeline matches the oral histories describing a discarded PDP-7 used to bring up the first Unix systems in late 1969. So here's the full table of all of the system ships to Bell Labs, with each system option taken from the 18-bit service list provided by Bob Supnick. And you can see that serial number 3 worked like this, and 34, 44, and 149 were the different machines. But while doing this research, he came across another surprise. Version 0 Unix could run on only one of the PDP-7s. Of the 99 PDP-7s produced, only 2 had hard disks. Serial number 14 had an RA01, presumably a disk, though of a different type. In addition to the PDP-7 being obsolete by 1970, no other PDP-7 could run Unix, limiting its appeal outside of Bell Labs. By porting Unix to the PDP-11 in 1970, the group ensured Unix would live on into the future. The PDP-9 and PDP-15 were both upgrades to the PDP-7. So to be fair, PDP-7 Unix did have a natural upgrade path, but the PDP-11 outsold the 18-bit systems by about 600,000 PDP-11s to 1,000 for the PDP-7 upgrade kits. Ken Thompson reports in a private email that there were 2 PDP-9s and 1 PDP-15 at Bell Labs that could run a version of the PDP-7 Unix, though these machines were viewed as being born obsolete.
Well, that's very cool. And yeah, Warner Losh is definitely the person who has a lot of knowledge about these old machines and the days gone.
Yes.
Excellent. A little bit modern stuff is coming from the NetBSD blog currently. They are still working on LLDB integration, and they now have watchpoints, xstate in ptrace, and core dumps. So they write that upstream describes LLDB as a next-generation high-performance debugger. It is built on top of LLVM/Clang toolchain and features great integration with it. At the moment, it's primarily supporting debugging C, C++, and Object-C code, and there is interest in extending it to more languages. So in February, they started working on LLDB as contacted by the NetBSD Foundation. So far, they've been working on re-enabling continuous integration, squashing bugs, improving NetBSD core file support, and lately extending NetBSD's ptrace interface to cover more register types and fix Compat32 issues. They had the May report to cover more of those. And in June now, they finally finished the remaining ptrace work for xstate and got it merged both on NetBSD and LLDB, meaning it's going to make it into NetBSD 9. And they also have been working on debug register support in LLDB, effectively fixing the watchpoint support. And once again, they had to fight some upstream regressions. And they talk more about this in detail in each of the next sections. For example, in the ptrace, the xstate interface, they noted in the previous report that they were comparing 2 approaches to resolving the unpredictable xsafe data setup, or the data offsets. And both solutions had their merits, but eventually went with having a pair of requests with a single predictable extensible structure. And as a result, they have implemented now 2 new ptrace requests. And with the main features of this new API being that it provides a single call to obtain all supported xsafe components, which is useful for YMM and ZMM registers whose contents are split between the disjoint xsafe components, provides a bit field that clearly indicates which xsafe components are available and which can be used to issue partial updates via pt_setxstate. There are a couple more of those benefits, so they went with that. From the user's perspective, the main gain is ability to read the YMM, the AVX registers. The code supports ZVM, the AVX 512 registers as well, but they have not been able to test it due to lack of hardware. That said, if one of the readers is running NetBSD on AVX-512 capable CPUs and is willing to help, please contact the author and they'll give you some tests to run. And there's a bit more about the xstate and core dumps. The ptrace xstate support provides the ability to introspect registers in running programs. However, in order to improve the support for debugging crashed programs, the respective support needs to be also added to core dumps. So the NetBSD core dumps are built on the ELF file format with additional process information stored in the ELF nodes. Nodes can then be conveniently read via the readelf-n command, and each such node is uniquely identified by a pair of name and numeric type identifiers. And then the NetBSD specific nodes are then split into two groups, the process specific nodes and LWP specific nodes. With the two process-specific nodes in use at the moment, the ELF node NetBSD core proc info containing process information, and the ELF node NetBSD core AUXV containing auxiliary information providing the dynamic linker. And there's a bit more downs there about the LLDB debug registers and the watchdog support. So that's the next item on their to-do list, and I guess we'll see more about that in the future. They also caught a couple of regressions by the build bot that they listed there, and I guess also reported upstream or fixed it in their own code. And the future plans list that since Camille has managed to move the kernel part of threading support forward, they're going to focus now on improving the threading support in LLDB. Most notably, this includes ensuring that LLDB can properly handle multi-threaded applications and that all thread-level actions like stepping, resuming, and signaling are correctly handled. And as mentioned above, this also includes handling watchpoints in threads. They also trying to finish the work on XState and core dumps and handle any possible bugs they might have introduced in the earlier work. And the remaining to-do items are to add support for backtrace through Signal Trampoline and extend the support to libexic info, unwind implementations, and then examine additional CFI support for interfaces that need to provide more stable backtraces. The second item is that they add support for i386 and AArch64 targets. The third item on the to-do list is to stabilize the LLDB and address breaking tests from the test suite. And the fourth is to merge the LLDB the LLDB itself with the base system. Very cool. This work is also sponsored by the NetBSD Foundation, and if you donate to the NetBSD Foundation, then you basically support part of this work. Okay, let's dive right into the Beastie Bits this week. Project Trident 19.07 is available.
Yep, so there's basically the next monthly snapshot of Project Trident, which is the continuation of the old TrueOS desktop. And this also has their new package base version, basically a version of package base built from the ports tree instead, and it allows it to have flavors. So instead of having hundreds and hundreds of packages, you get a basic set, bin, boot, conf, devel, lib32, rescue, and sbin. And then they have flavors. You can get generic, minimal, and no ZFS. The concept with the no ZFS one is then you can use the new port of ZFS that's in the ports tree without it interfering with the ZFS system base. So an interesting way to try out that work as well.
Yeah, and give some feedback, how you like it or what kind of use cases you use it for. That's a nice way of seeing that Project Trident is making progress. Then we have a thing called a list of names from Cold Blood. Any familiar?
Yeah, so they're saying, someone here from the Montana Linux blog was saying, I watched this fairly cheesy Hitman/action movie today, and there was a scene in where a police detective was looking at a list of phone numbers. When I saw it, I had to freeze the screen and look at all the fine names that were on this list. I'm guessing that none of the phone numbers attached are real, or are they? So in this case, the movie is drawing your attention to this Malcolm person who doesn't have a last name and whose phone number there is highlighted in yellow. But if you look at the rest of the list, you see names like Daniel J. Bernstein, Kirk McCusick, Theo Durat, Eric Raymond, Larry Page, Sophie Wilson, Will Wright, and many other people that you might recognize.
From the Unix space, yeah.
They say, most of them I recognize, but a few I didn't. When I looked up the few I didn't recognize, I learned that we still fell into the same pattern. So how many of these names do you recognize? And they say, and just in case you were wondering, this movie has absolutely nothing to do with computers, so someone snuck this good list into this movie, even though it was unrelated.
Yeah. Hey, we need a list of random names with a random number into to look up. Okay, here's one.
Yes, because they didn't try very hard to make these look like phone numbers because a lot of them start with 0 and so on.
Yeah, these don't work normally. Yeah, that's a nice Easter egg into the movie because I guess they didn't notice that.
Yeah, just kind of like the BSD workstation thing getting into Die Hard doesn't have anything to do with the movie, but somebody snuck it in there anyway.
Yeah, that's right.
I wonder if through some cruel twist of fate, it was actually the same guy.
Oh, yes, working in the movie industry, trying to promote Unix and open source.
I have no reason to think that, but I just think that would be cool. Although just as cool if there were more than one of them, obviously. But.
I guess someone with enough time can do the research there and report back to us. Oh, then we found Fern, a curses-based Mastodon client modeled off Usenet newsreaders and Pine with an emphasis on getting to timeline 0.
So this is the federated editor and reader of news.
Ooh.
And I guess the point is to read all of the social media, which seems like a slightly strange task.
There's, better ways to spend your time.
If you want to make sure that you don't miss certain messages, I suppose that actually makes sense.
Oh, sure. Yeah. In certain different networks, you can find that if you have a combined client, it's easier to follow along.
Yep. And it says it has a pager facility. So if you just press G, you can read the longer messages. And if you set the browser environment variable, for example, to W3M-T, text plus HTML or whatever, then it can also automatically fire up your browser when you try to look at a picture.
Yeah, well, why not? I mean, there's a use case for that. Oh, next thing is good news from the OpenBSD world. OpenBSD community goes platinum for 2019 over at undeadly.org, of course. Ken Besterback reports from the OpenBSD Foundation that the OpenBSD Foundation is happy to announce that individual contributions from the OpenBSD community have again exceeded Canadian dollars 50,000, making the community the first platinum level donor for 2019. Excellent. These smaller regular contributions are the backbone of longer-term spending planning. The Foundation would like to thank all the individuals who made and contribute to making regular monthly donations or contributions. Yeah, that's definitely good. And good having the community feedback and the support from the community as now platinum level is good for the OpenBSD Foundation to have a more stable financial planning horizon for this way.
In the comments, somebody else points out that since the CD sets are no longer being sold, what's the preferred means to support the project? And somebody links to the OpenBSD Foundation page that's being discussed here. And then there's also discussion of currencies and so on. But yes, the OpenBSD Foundation is how they have the hackathons and also make sure developers have modern laptops and so on. And it's important to the development of OpenBSD.
Oh, yes. It directly goes into the project and helps do a lot of good things there.
Yeah. Supports OpenBSD and related projects like OpenSSH, OpenBGPD, OpenNTPD, OpenSMTPD, LibreSSL, Mandoc, etc.
Yep. Very cool.
And if you go to the activities page, they have a list of things that they actually funded. So if you look at 2018, you can see funded several development machines for OpenBSD developers or replacement laptops or continued development of the AMD GPU/Vega support, which involves buying those cards and actually paying someone to work on stuff, updating hardware for things like the mail server, running a bunch of hackathons in different places, or even buying new UPS batteries.
Yeah, small things like that can go a long way.
Mm-hmm. Then lastly in the roundup, we have the Dragonfly BSD roundup, TCP keep alive and deports on Dragonfly. So Dragonfly's TCP keep alive code has been changed from milliseconds to seconds. This happened in both Dragonfly current and in the 5.6 release, and is changes the network API, which means a deports rebuild was needed to match the API change, or a package upgrade if you're using package, which all the official packages have already been rebuilt and you can just update.
So it's time for feedback and questions this week. Always send us more feedback and questions, especially questions for this segment, to feedback@bsdnow.tv. Anything that you find, comments, questions, show ideas, topics, or stories that you found on the internet. So that will go into the show in a future episode. The first one this week is Patrick with an OpenZFS or ZFS on Linux module from ports. Hey guys, great to see that the grand unification is making progress. I wonder what the current concept regarding kernel upgrades is when ZFS is installed from ports. Consider, for example, I'm running FreeBSD 12.1 with OpenZFS from ports. Now, how do I upgrade the system to, for example, 13.0?
Right, so if you were just upgrading from 12.1 to 12.2, it probably should be okay. But yes, going to a major version can be a problem. So he points out that there is a system for make.conf for source.conf called ports_modules. As he says, as far as I have observed, simply rebuilds and installs the port on the running system, but it is, as far as he can tell, mandatory to build and link the module with a future system. So the port module thing, remember, is building against whatever's in user source, not what you're running. And so as long as you've updated your source tree to be 13, it would compile the module for 13. In most cases, if you're using binary packages, what you're probably going to want to do is just execute a certain package command to install the package from the 13 repo, even though you're still running 12, basically. So you'll run FreeBSD upgrade or whatever it is you want to do to upgrade, and then install the module from the 13 repo onto your system and then reboot.
Oh, okay. So that's how it works.
As he notes, if the module is not critical to system operation, for example, the VNet or VirtualBox networking module, then you can just upgrade after you reboot into the new OS. But if it's your file system, that'll be a problem. Obviously, yes. So, yes, it's something we're going to have to work out. It's mostly fine. It's just a matter of figuring out the instructions for people to make it easy.
Yeah. If you don't get that right, then you kind of lose your system or not make it boot properly.
Yeah, if you are running the 13 kernel, it won't want to load the 12.1 kernel module, and that'll be a problem. And so likely we'll just have to add an extra step to upgrade instructions. Part of it might also be that, 13 maybe will ship with a kernel module that will be relatively close to what is in the ports tree at the time. But yeah. It's not 100% figured out yet.
They're still working on the fine bits of how to make that upgrade possible. Once we're in that space, I guess there will be a path forward always, or instructions to bring you there. All right. Thanks, Patrick, for this question. I guess it's not your first one if you're the Patrick that I think you are. And thank you for this question. Next one is Brad. Question about services not starting. Oh, okay. Here we go. Hello, Alan, Benedict, and JT. I'm having a problem on my laptop and desktop machines, both ringing FreeBSD 12.0 release, patch level 5 currently. I'm researching and troubleshooting on my own, but hope one of you gents might have seen this or might have other suggestions. In essence, services are not starting at boot. Specifically, cron, sendmail, and sendmail.msp_q. I initially found that cron was not working after setting up ZFS auto snapshot. I noticed that snapshots were not being taken and searched it down to cron not running. I can start it from the command line, but it just doesn't start at boot. Everything else seems to be starting normally. Have any of you seen this behavior before? I posted a thread on the FreeBSD forums, but have been unable to so far run this problem to the ground. I think you had a little bit of a follow-up with him.
A little bit. So the only time I've seen something like this was actually recently on one of the machines at the office when they installed PCDM, the TrueOS login manager.
Yeah.
And so it was starting as part of the startup, but because that machine has a complicated history, but I think they got the version of PCDM that expects OpenRC, and so it doesn't fork off into the background. It stays running, and so it blocked, and nothing after it ever started.
Oh.
So SSHD didn't start, crond didn't start, and NTPD didn't start. So yeah, I'm wondering if something in your startup process is actually not finishing.
Coming to that point, yeah, to start the cron or sendmail.
Yeah, so like when this was happening on Stefan's machine, it never got to a login prompt, actually. It got partway through startup, and then it switched to the graphics startup screen. But if you went back to the,
console,
TTY1 or whatever, you would see that it never actually made it all the way to the login box.
Oh, okay. So this is probably a system that migrated from a previous version to FreeBSD 2.0 release, and it's not a freshly installed system?
Yeah, that one was a very complicated history starting with FreeBSD 10.
Yeah, and maybe this is the same that Brad is experiencing here?
Oh, but yeah, it's probably just some program in his startup process is not actually exiting and letting the things after it happen.
So how do we approach that? Do we try to identify the problematic service?
Best way is probably looking at the logs and seeing what's the last thing that started and why the other things didn't start.
Yeah, maybe it's some leftover from a previous experiment or some other installation bit that didn't finish properly or wasn't upgraded in the proper way. But yeah, the logs should tell you how far it would get, and then work your way from there backwards. Try to disable other services until you find the one that's making problems. I mean, you cannot disable all the services because they're kind of important. But if it's not a non-essential service, then you might be lucky and get the right one.
Yeah, but most likely I think it's that something in the startup process is blocking forward progress.
All right. Yeah, well, if you found something else, then please reply to us, and then we can continue our debug session or mention it in the future feedback and questions part, because it might be that other people have encountered this before and don't know their way out as well. And so if there's a solution, then we should probably tell people. Okay, Simon is next and last with feedback. Oh, we always love feedback. So here goes. Hi, Alan, Benedict, and JT. Greetings from Sydney, Australia. Oh, wow. That's far away off where Alan and I am. First time writing in. Love the show. Great. Look, good to read that. Have not missed an episode since episode 1. Oh, great. Keep it up. Your show is really appreciated. Thank you. We like that feedback. A friend of mine recently swapped out his consumer home router for OPNsense running in a VM on a server. He's attempting to create some scripts to track bandwidth usage and is scraping the output of netstat periodically and recording the I-bytes and 0 bytes numbers in the database. Command for netstat -i-b-n-l-l-em1, the interface. The problem he is now facing comes about when the machine reboots. Is there a way to capture the two numbers just before the interface is torn down? I was trying to dig through RCD scripts to see if there was a way to shoehorn a pre-shutdown script to run on in there. Any ideas would be greatly appreciated.
So I talked to this person on IRC a bit. So yeah, they were trying to use just netstat and figure out the counters and try to dig through them during shutdown. Probably more likely what you want to do is grab the number every 5 minutes and compare it to what the number was 5 minutes ago, using either netstat like that or something like SNMPD, and then do that. And there are a number of programs under NetMGMT, Network Management, in the ports tree that do this for you. Because by getting the value every 5 minutes and just subtracting what it was 5 minutes ago, you'll get much more accurate results than just trying to capture it at shutdown, because you'll miss it if it crashes and so on. And you'll be able to graph it over time as well and be able to see differences in timeout day and so on. And then as long as you're using 64-bit counters, then it'll be easy to tell when the number reset to 0 because of a reboot, because you'll know, obviously the number didn't go all the way to the maximum value of a 64-bit number, which is, 18 billion bytes or whatever, back to 0. It most likely just was a reboot.
Okay, yeah, thanks. Greetings to Australia. Never been there, but maybe one day. Thanks for that feedback, Simon. And that pretty much wraps up this week's episode of BSD Now. Thank you for listening. And again, if you have anything BSD related, then send it to us at feedback@bsdnow.tv, and then a future episode might cover it.